minus k equals a f of b x minus h, bracket, bracket. That's everything put together. So we have a k, we have an a, we have a b, and we have an h. Which one of these letters is a vertical stretch? F stands for the function. So F is not even in play here. A is the correct answer. I'm actually going to say the absolute value A because I don't want to talk about negatives here. Okay, so if the absolute value of A is greater than 1, what is it? Stretch or compression? Stretch. If the absolute value A is between 1 and 0, that's when we have a compression. Okay, what about horizontal stretch? Which letter would that be? B. And again, I'm going to say it as B. So when B is greater than 1, what is that? I learned this yesterday. It's a compression. And when B is between 1 and 0, it is a stretch. Okay, what letter would reflect it over the x-axis? Not K. Yes, A. A affects the y values. When A is less than 0, it's a reflection over the x-axis, right? How about a reflection over the y-axis? Okay, so which one would be a reflection over the y-axis? Yes, B. And that's when B is less than 0, negative, right? Okay, which letter would be the horizontal shift? H. H, it's inside the brackets, right? It's affecting the x. So, when H is greater than 0, watch this. There's a minus in my form already. So if H is positive, it's going which way, left or right? How about right? I'll give you an example. If H is 5, do you see I'll get x minus 5? The minus is part of the form. Yeah. As long as you understand, do you see if H is less than 0, it would be, like say it was minus 1, it would be x minus minus 1, which really is x plus 1, which means it's going left. Also, watch the K. K is on the left-hand side here. So if K is positive, like 5, what would it do? Go up or down? It will go up. It would be, it's negative on this side, it'll be positive on this side, right? Okay, and then if it's less than, it's going to go down. Okay, of course, it doesn't make sense unless we have numbers here. So, before I move on though, the thing you got to watch though is, in this form, the B, as you learned on your last night's homework, is a reciprocal factor, meaning if this was f of 2x, the x is not doubled, it's halved. It's a reciprocal factor, so that's why it's 1 over bx. And then, of course, it's the opposite sign that happens to the x, right? Whereas a is a direct thing. A is multiplied by y, then added k. And, of course, f, I already talked about this. F actually stands for the notation of the function. So if you were doing some of the worksheets, they actually define the function to be, say, a squaring function. So then the f went away and it ended up taking over the input and squaring it. I don't know if you noticed any of those questions. Okay, maybe it'll be today. And the most important thing, if you look at this, do you see that B is factored out? You cannot tell anything about H unless B is factored out. We haven't had them both happening at the same time before. But that's so important. You need to factor it out to be able to tell anything. B must be factored out. Okay, who can tell me what's going on here for A? And remember that we have to follow the bed mass rules. So we have the bed rest rules, that's right. So we got to do multiply before addition and subtraction, right? Now, X and Y have nothing to do with each other. So if you want, we can deal with all X's first, then all Y's first. Yes? Okay, so let's take a look at my X first. What happened to X first? Okay, so again, we got to follow bed mass. We do the multiply effect before the adding effect. So what happened here? No, we are looking at the brackets. We have to do the B before the H, is what I'm saying. Is the X's getting multiplied by a half? The correct answer is no. It's getting doubled. The X's are getting doubled. So it is horizontal stretch factor 2. Then what happens? Which way do I go after that? What does the 4 do? Right 4, yeah. Okay, what happens to my Y now? Multiply effect happens first. Okay, vertical stretch factor 3, then what? Down 5. No, only X inside the function. It's not what you think it is, right? Okay, this time for B, we're comparing it to Y equals the absolute value of X. So this is the original graph. See, in this notation here with the F, we don't know what the function is. It could be a squaring function, an absolute value function, a reciprocal function. Here they're actually defining the function. They're saying it's an absolute value function. So what's the first thing we have to do in order to look at all this? Factor out the B. So I'm going to, and if you want, you can move the 5 over. It's up to you. So it has to be 2 bracket X minus 2. Yes? Okay, let's deal with the X's then. What happens first for the X's? Not divided by a half, multiplied by a half. Dividing by a half means it's getting doubled, right? You gotta watch your words. So we don't use multiply, we have to use the term horizontal stretch. Okay? So horizontal stretch, factor what? A half. You could say horizontal compression factor too, but I don't think I want to get into the compression things. So horizontal stretch factor a half. He's getting half, you know. Then what? Then right 2. Okay. You good? Then what are we doing for our Y's? There's 3 things happening for the Y. Multiply effect happens first, though. So, what would that be? Vertical stretch. We got to describe it properly. Vertical stretch. Factor. Factor what? 2? What else happens before we shift? A reflection and a reflection over the what axis? Over the x-axis. Then what happens? Up 5, yeah. Then up 5. Next one. What's wrong with the way this question is worded or given? Given the graph of f of x, describe the transformations to obtain the graph of y equals f of 3x plus 6. So what's the first thing we have to do? We need to factor out the 3. So this is equal to f of 3 bracket x plus 2 bracket bracket. Has to be in that form. Now we can actually look at it and see what happens. Who can tell me what happened now? Horizontal stretch factor a third. Good. Then left 2. Very good. We're getting this now. Okay, this one's a little worded differently. This time we're stating the actual coordinate point. We're starting with x, y, and these things happen. What would be my new point? So you're not describing what's happening, you're coming up with a new point. So I'll help you with A and then I'll get you to work on B. So if we're talking about x, what's the only thing that happened to x in A? Yeah, I went to the right one. So my new point would be x plus 1. Okay, look at my y. What happened to my y? Vertical stretch factor of 3. So how would that affect my y? It would now be 3y. Very good. Yes, and then it went up 5, so plus 5. Okay, try B now. Try B. Okay, so the first thing you have to do is factor out this. So I'm going to rewrite it. Y plus 4 equals 2/3 f 3 bracket x plus 3, yeah? Okay, what happens to my x? Yeah, it gets thirded, so 1/3 x. Yeah, and then it went to the left 3, so minus 3. 1/3 x, because it's a multiply effect. Y, what happens to y? Multiply by 2/3, then down 4. Very good. Okay, we're getting this. Right on. Okay, now we have a graph. Sometimes because there's so much stuff going on, this table of values, again, I call that loosely table of values, more a chart. This helps you way better than trying to do everything at once on the graph. So notice I actually moved the -1 to the other side here in my chart. So can anybody tell me what my new point would be if my old point is xy? What happened to my x? It got multiplied by 2, so it's now going to be 2x. What happened to my y? It got multiplied by 2 as well. And then add 1, yeah, up 1. So now, because I kind of have the rule of the what the coordinates are happening, you could just take -3, plug it in, you get -6. 0 goes in, 2 times 0 is 0, plus 1 is 1. Do you see how I'm using the chart? Then I'm going to plot -1. 0 goes into 2 times 0 is just 0. 3 goes into this rule. 2 times 3 is 6 plus 1 is 7. So 0, 7. 2, 3. 2 goes in, I get 4. 3 goes in, I get 7 again. So 4, 7. Three goes in and it gets doubled, so we get 6. 4 goes in, it gets doubled, 8, 9. So 6, 9. 6, 9, 8, 9. So it's going up like that, right? Any questions there? Okay. So what's happening here, and I know yours looks a little different, I apologize. This is the one that I start with, and then something happens in A. So how would you go about trying to come up with the formula? If you compare the original to A, is there a quick thing that you could tell that happened? Yeah, this one got a reflection over What? Y-axis, it looks like it moved up. Okay, so what you need to do before you make a decision, because this is going to be g of x, something f of x, you know, whatever happens there, you got to compare. For instance, this point is negative 2, 1. Because it got reflected, you're now comparing this to 3.5, right? You're going to compare this one, which is negative 1, negative 2, to this one, which is 2, negative 1. Okay, so I'll give you a moment to figure this out. You can do A and B. Okay, so I am going to compare this, number 1, to this, number 1. Yes? So I'm just going to look solely at the x's. Negative 2, I said, got reflected over the y-axis, so it became positive 2. But then all of a sudden it was 3. So my first inclination is it must have got shifted to the right 3. So then I kind of take a leap. I say, I think it's going to the right 1 to get to 3. So then you try the next point. Here's number 2. Compare it to number 2 over here. So let's see what happens to my x. Negative 1 gets reflected, so it's now at positive 1. Then right 1 gives me 2. I think I'm right. Maybe do a third one, just in case. Let's try this one over here. This coordinate is 2, 4, and that would be, which one here? This one? Negative 1, 2. So 2 gets reflected, negative 2, then right 1, I would be at negative 1, so it works. So I'm going reflection over the y-axis, right 1. How would I do that? I need some more room here, I think. Reflection over the y-axis is a negative b, but I'm not going to write a b. It's like a negative 1. And then I'm going right 1, so x minus 1. Okay, now I'm going to do the y. What happens to the y? 1, all of a sudden magically becomes a half. So I take a leap. What do I think happened? It must have got vertically stretched a half. So let's see if it works now. This one. It went from negative 2 to negative 1. Oh, that's half again. Let's try the third one. 4 became 2. So that's exactly what happened. So there is my full equation. G of x equals 1/2 f of negative bracket x minus 1. That one's a hard one. What's the visual thing that happened for the shape to be the same? There was a reflection, right? Reflection how? Reflection over the x-axis. It went like this and flipped up like that. That's the only way that shape could have went like that, right? So start from there. So because I'm talking about the reflection, you can start from the y's, or you can just look at the x's at this point, right? So compare negative 2 to negative 1. Then compare negative 1 to negative 1/2. What's your first inclination there? What's happening to the x's? They got halved. So how would I... So a horizontal stretch factor 2. Factor 1/2. But it's going to be an f of 2x is what's going to happen. Okay, so everybody agree that's what happened to our x. It got halved, so that represents f of 2x. Okay, now look at our y's. We know the y's got reflected over the x-axis. So for instance, my first point, number 1, the y value of 1 became negative 1. But then all of a sudden it's 2. What do you think happened? Take a leap. What happened? It went up. Okay, so we're thinking it goes up 3 afterwards. Let's try it on the next point. This y value is negative 2. It gets reflected, so now it's positive 2, but all of a sudden it's at 5. Hey, I think we're right. Up 3. Try a third time. Oh, we might try it at the 2, 4 one. The 2, 4 becomes 1, negative 1. So 4 gets reflected. So now it's at negative 4. And then up 3, negative 1. I think you're right. So how do I indicate a reflection over the x-axis? Yeah, negative a, so negative in front of the f of x. Yeah. And then how do I do up 3? Yeah, minus 3 over here. There we go.